Routing Information Protocol, or RIP, is a generic broadcast-based dynamic routing protocol supported by many platforms, vendors, hardware, and operating systems. It alleviates the need to manually configure static routes for adjacencies and neighboring subnets or routers. RIP is known as a distance vector protocol. As such, it uses a hop count to judge the distance from one subnet to another. This employs a simple metric which sends the entire routing table to directly connected neighbors. Called routing by rumor, RIP uses broadcasts that send the complete routing table out every 30 seconds by default. In a RIP broadcast, a packet serial number is given an initial starting value of 1. As it hops from router to router, the hop count is incremented until it exceeds 15. A hop count of 16 is considered unreachable, and the packet is then removed from the network. When a network's routers have advertised their adjacencies and neighbors to all the other routers on their network via broadcast, and in turn those routers have discovered all of their neighbors, we say convergence has taken place. RIP convergence usually takes less than 2 minutes, but is considered slow compared to other dynamic routing protocols like Open Shortest Path First, IGRP, and eIGRP. There are two versions of RIP, RIP version 1 and RIP version 2. RIP version 1 only does classful routing. It does not send any subnet information, so all devices on the network must utilize the same subnet mask. RIP version 2 does classless routing, also known as prefix routing, so it will transmit subnet information in its broadcasts. This means all devices on the network need not have the same subnet mask. Let's configure RIP on our Routing and Remote Access Services server. We implemented static routing, now let's implement a dynamic routing protocol. And I'm going to go here, I'm going to say new routing protocol, and I'm going to add RIP version 2, which is broadcast based. It's a dynamic routing protocol, and what it'll do is it'll go out and send broadcast packets, known as advertisements to other routers to let them know what interfaces it's adjacent to. So it'll basically broadcast its adjacencies, and then they'll broadcast their adjacencies. And after about maybe a minute to 2 minutes, we'll have something called convergence, where they all kind of, synchronize their data, and they learn about each other's networks, and then they will basically automatically populate the routing table with routing entries. So how cool is that? So I've added these two interfaces to RIP. RIP's going to go out and start broadcasting and listening. And now I need to go ahead and configure RIP on my other devices as well. So here I'm on the Galactica, and I've activated RIP, and it's listening. And now I'm going to go to some of my other servers. Now let's configure the router gateway with RIP. I'm on my router, my firewall on my router right now. I'm going to go ahead and delete the static route that I had added. And now I'm going to go over here and set up RIP again. And RIP's running on my router. Let's configure another 2008 Routing and Remote Access Services server on a separate subnet with RIP. And now we're on the Cylon base chip. Ha ha ha. I know, it's adorkable. Okay, well, maybe not, but anyway. And our Cylon base chip is on a completely different network and subnet. So I need to set up routing and remote access here too. And, I installed the role, but I need to configure a LAN router. I'm going to run the wizard, say custom configuration, next, LAN routing, next. Go with the defaults, ignore the nag about the network policy. Alright, and I went from a red area to a green area, so things are good there. And I just want to add, again, the RIP protocol to RIP version 2. And I need to add my interfaces. My private and my public. And then RIP will start, again, advertising its adjacencies on this router, the Cylon base chip and Galactica, which is a completely different network and subnet and domain controller. Matter of fact, these are two different Active Directory forests here. Different subnets, different networks, different forests. I'll just show you the FQDN. Alright, so Cylon base ships, Galaxy. And then basically these guys are going to start communicating and broadcasting with the router and with each other. The two 2008 servers as well as the router. They're all running RIP, so they can learn about each other's adjacencies. And I can go over here and click on Show Neighbors and see what I've learned so far. I've discovered the gateway, and I've discovered 14, which leads to the other network. That's the 220 Class C network. Okay. So let's hop on over to the other. And now I'm on Galactica. And let me do a refresher. And again, you can see, this is responses sent and received, so it's learned about its neighbors. We'll do show neighbors and discover 19. And let's see if let's hop on over on a Windows 7 client. So using RIP, let's see how far we can get. And I'm going to ping. Okay, so that's my local private area network there. And now let's forget the other side of the domain controller. I'm going to ping. Okay. Now I'm going to see if I can ping the gateway. And I can reach the gateway. And let's see if I can reach the other side of the third network or third subnet. I can reach there.